So, welcome to the next lecture, that is just continuing as a introduction to organic crop management. So, here we will discuss about the nutrient management. So, look how we can go for the nutrient management means we will discuss what do you mean by nutrient management and how we can go ahead with the nutrient management practices. You see nutrient management as you discussed earlier, that means you have to manage all sources of nutrients available, either the native soil present, the nutrient present native soils, or the organic matter present in the soils, and the biological resources you are adding, the organic resources you are adding, or biological N fixation. Those things has to be taken into account for nutrient management. That means the factors to be considered are amount of plant available nutrients already present in soil, as you discussed when you go for the nutrient recommendations, amount of nutrient to be applied. So, we must know how much plant available means the mineralizable nitrogen nutrients present in the soils at the time of your planting or the sowing of the crop. Then nutrient use efficiency of the crop is a crop specific, depends upon the yield of the crop, how much yield you are targeting yield of the crops, and the efficiency of the crops, that means the nutrient may be lost due to several processes as we discussed earlier, maybe nitrogen leaching, volatilizations, denitrification losses are there. So, how much that indicates the use efficiency of the crop, that also depends upon the method of application, how you are applying the nutrient, that indicates the use efficiency. Then physico-biochemical needs of the crops, that means requirement of the crop, that is the nutrient content of the crops, and the organic matter content of the soils, that is organic status of the organic carbon status of the soils. So, when you go for nutrient management, the better nutrient management, we have to have the basic informations about the soil, that means the nutrient available in the soils and nutrient requirement of the soils, and the use efficiency by the crop, and finally, how much we need to apply this. So, these are the main 4 things. So, if you say how much yield you are targeting, how that means that indicates how much nutrient requirement by the crop. So, if demand is known, then how much available from the soil, either from the mineralized source or from other sources is available from the soil, then we need to calculate how much nutrient to be applied based on the efficiency factor. What are the losses? Looking at the losses, how much nutrient can be applied. So, these are the factors to be considered when you go for the nutrient management. So, basically there are the 4 R's in precision nutrient management. The first R is the right quantity, that means you have to know how much quantity of nutrient required for the crop. The second R, the right source. Source means whether you can go for the organic source. In organic source, the different type of nutrients you can go for compost, vermicompost, crop residues, or as you discussed enriched vermicompost. So, the source, what type of source you are using. Then when you are using, right time, what time, that is very important, because the crops require nutrients some specific growth stages. So, your nutrient application should be at the time of need, critical growth stages, I can say the growth stages where the crop needs the nutrients and what are all the inputs, and very sensitive, the crop has become very highly sensitive, any shorts or any deficiency of nutrients or waters at that stage, of course, the crop becomes highly responsive to application of nutrients. So, those are the critical stages, timing of nutrient application, that is also very important. And the 4th R is the right method, what method you are using. So, that indicates the loss. If you are using suppose broadcasting, then there will be less efficiency, but if you are going for placement, deep placement at the right zone, then that efficiency may be higher. So, when you, so these are the 4 R's for the precision nutrient management. You have to select the right source, of course, fertilizer. You have to calculate the right quantity of fertilizers. You have to apply fertilizer right time when the crop needs, and you have to apply fertilizer in right method, so that your efficiency is higher, loss is less, and especially when you go for the organic farming. So, right method is also very right method, right quantity, right source. You must apply right method, so that loss is less, the environment is protected, and you should apply right quantity. So, loss can be minimized, that can have a less damage on the environments, and the right source should be used to have the organic source, and right time for the yield improvement. So, to recommend the nutrient quantity, in general old method, conventional method is the blanket or the general recommendations. Usually the farmers are following the traditional way, how it is done as a conventional method for the N recommendations. General recommendations are based on large number of experiments conducted at different locations, and the general fertilizer recommendation is equated with the medium fertility status of soil. And for low and the high rating soils, the dose is correspondingly decreased or increased by 25% of the recommended dose. So, this general recommendation is basically for the soils of medium fertility. The soils are categorized of low fertile, medium fertile, high fertile, that you can see the right hand side here, based on the content of organic carbon, available nitrogen, available phosphorus and available potassium content of soil. The soil is rated as low, medium and high fertility. If the organic carbon content is between 0.5 to 0.75%, this soil is rated as medium, content less than 0.5% is low and higher than 0.75 is the high rated soil, high fertile soil. Similarly, available nitrogen between 280 to 560 kg per hectare is a medium fertile soil. If less than 280, the low fertile soil, higher than 560 is a high fertile soil. The phosphorus, if it is 10 to 25 kg per hectare, it is a medium fertile soil, less than 10 it is a low fertile soil, higher than 25 is a high fertile soil. Similarly, potash, the range of 108 to 280 kg per hectare is a medium fertile soil, less than 108 is the low fertile soil and higher than 280 is a high fertile soil. So, based on the soil fertility status, so we can recommend the general recommendation is given, and if the soil fertility status is low or high, so the fertilizer level either the increased or decreased by 25%. So, for example, for the nitrogen dose of rice, if you see for the general recommendation for the medium fertile soil is around 100 kg nitrogen per hectare, especially for the transplanted rice. If the soil is low fertile, then we need to fertilizer by 25%, we dose of 125 kg N per hectare. If the soil is high fertile, then we have to decrease the fertilizer dose to up to 75 kg N per hectare. So, this is how it is done for the soils of medium and low or the high fertile, but this has some problem, that means as you understand, because soil is categorized to medium, low, high irrespective of the crop. This is a property of soils without considering the crop demand. Crop need is without have a linkage to the crop need, this soil is categorized as low, medium, high fertility. Moreover, crops have variable requirement of nutrients and they respond differently to applied fertilizer in different soils. So, this is a we can say blanket or the general recommendations which is not specific. Usually the farmers in the farmers field they go for the traditional way of applying fertilizers or the calculating the requirement based on the blanket recommendations. But we will discuss how you can go very specific for a particular soil, for a particular crop. So, this is called as a balance sheet method, the nutrient recommendations using balance sheet method. So, that we can have a specific nutrient requirement for the crop. We can calculate the nutrient requirement of a particular crop for a particular soil using this balance sheet method. So, as y into b is equal to n REC plus n MIN into E1. So, plus n O into E2 plus A into E3. So, y is your the left hand side, y into b, this is your demand of nutrient by the crop or the nutrient removal by the crop for a particular target yield. So, y is a crop target yield, that is your kg per hectare, and the b the nutrient uptake by the entire crop per unit yield, that uptake by the both grain and the straw as a byproduct. So, how much nutrient is taken by the crop for the kg of yield, kg uptake per kg yield of the crop. So, if you multiply the yield with the nutrient uptake by the crop, then this will give the nutrient demand or total nutrient removal by the crop from area of 1 hectare. And the right hand side, this should be balanced, this much nutrient should be balanced either from the soils or from the external applications. So, these are the soil sources, N mineralized nitrogen, the source from soil, that is N mineral amount of mineral N present in soil kg per hectare, that is available nitrogen present in the soils before planting or sowing of the crop, the inherent fertility of the soil. Similarly, NO, that is amount of N mineralized from organic matter, because soil has organic matter and there is slow mineralization process, they also contribute to nutrient requirement of the crop. So, that is a NO, the amount of N mineralized from organic matter present in the soil, that is in kg per hectare, and Na, amount of N supplied to soil through dry and wet atmospheric deposition. That means, if there is a rain in the field, so it is expected that during the rainfall, if you know the expected amount of rainfall also they contribute to some amount of nitrogen in the soil. So, how much nitrogen comes from the rains? So, that is taken care. So, E is the efficiency factor. So, that because of loss, because from any of the source they are not 100% efficient, they loss from different sources. So, E is the efficiency factor for this loss. So, looking at this, if you see your left hand side is the demand of the crop, and the demand must be met either from the sources from the soil, either the N mineralizable source or organic source or atmospheric depositions, and rest has to be NREC, has to be external application, that is say as a nutrient recommendation kg per hectare, how much nutrient to be applied after meeting the requirement, after knowing the available nutrient from the soil. We will do a sum on this how to calculate this one. Suppose you need to calculate balance sheet method, the compute the N recommendation kg per hectare for rice crop with the following information. Suppose yield is grain yield 5.0 ton per hectare for grain yield and 4.0 ton per hectare for straw yield, those are on dry wet basis. Because when you go for the nutrient uptake, especially on dry wet basis, we assume so there is no moisture. And the B, the grain nutrient content, the grain N content 1.5% and straw N content 0.8%, and N mineralizable, that is available nitrogen soil through mineralization source 150 kg per hectare, and nutrient can be mineralized from the organic matter present in soil during that growing periods, that is 20 kg per hectare, and from the rain or atmospheric deposition it may be 5 kg per hectare. These are source available from the soil, and these are the efficiency factors E 1.4, E 2.5 and E 3.4. If you put this one to calculate the how much nutrient requirement for the crop. So, you do the calculation here. So, your left hand side y into b, your grain yield is 5 ton per hectare, that is your 5000 kg into nutrient content or grain nutrient content 1.5%, 1.5 by 100 plus your straw yield is 4 ton, that is 4000 kg into straw nutrient content is 0.8%. So, the total demand of the crop is equal to, this is 500 into 1.5 by 100. So, this is 75 plus, and this comes for 4000 40 into 0.8 32. So, that is equal to 107 kg per hectare. So, this much of demand to meet the yield of 5 ton per hectare as the grain yield, 4 ton per hectare as the straw yield, and the grain nutrient content 1.5% and straw nutrient content 1.8%. In that case, your nutrient demand is 107 kg per hectare. And if you see the right hand side, you see that should be met. So, 107 is equal to N recommendation REC plus your N mineralized nitrogen present 150 into 0.4, your efficiency factor U1 plus the organic source nitrogen, you have probably 20 kg per hectare into 0.5 plus here the atmospheric depositions, that was 5 kg per hectare, efficiency factor probably 0.4. So, if you see this one, this is 0.4 into n recommendation plus 150 into 0.4 is 60 plus 20 into 0.5 10 plus 5 into 0.4 2. So, this is your 107 or so n recommendation from here if you calculate what how much recommend n is equal to 107 minus 60 plus 10 plus 2 72 divided by 0.4. So, that is equal to so this becomes 35 right 107 minus 72 7 minus 2 5 10 minus 7 3 35 divided by 0.4. So, that is equal to 4 into 0.4 350 8 32 8 3 and 7 around 87 right. So, it becomes 87 kg per hectare. So, this is how you can calculate the nutrient requirement, how much nutrient can be required by the crops. So, using this balance sheet because demand and the supply from different sources. So, as you know the demand is 107 kg per hectare. So, removal by the crops by the grain and straw as from the grain portion 1.5% nitrogen and straw content 0.8. So, this data the grain nutrient content or straw nutrient content this is a specially crop specific. It does not change there may not be a very significant changes due to management practices. However, the yield can changes if you know the target yield and you can know the nutrient content you can have a pre assumption you can before growing the crops we can calculate how much nutrient demand by the crops and looking at the soil status the soil analysis we can know how much nutrient available from the soil sources or other sources then how much nutrient is required. So, this is usually when you go for nutrient management we must understand we must calculate the how much nutrient required by for a particular crop for a particular type of soil. So, if you know this one the nutrient demand so, by using this balance sheet method, so you can calculate the quantity of the nutrient the first the 4 R's first R is to know the quantity of nutrient requirement by using this we can calculate the quantity and then the source of nutrient. So, depending upon the source you are interested to for the crop specific many sources are available the materials and these contents of nitrogen, phosphorus and potash. So, like cattle dung that contains 0.35% nitrogen, 0.12% P2O5, 0.17% K2O. Similarly, farm yard manure FYM that contains 0.75% nitrogen, 0.2% P2O5, 0.5% K2O and rural compost 0.75% nitrogen, 0.2% P2O5, 1.5% K2O, water hyacinth compost 2% nitrogen, 1% P2O5, 2.3% K2O, rice straw contains 0.6% nitrogen, 0.18% P2O5, 1.3% K2O because why rice straw sometimes we do incorporate the previous crop residue in the field. So, if you are growing the rice straw, wood straw or sugarcane whatever you are incorporating. So, you should know what the nutrient contents of these materials. Similarly, wood straw contains 0.48% nitrogen, 0.16% P2O5, 1.18% K2O, sugarcane trash that contains 0.4% nitrogen, 0.18% P2O5, 1.28% K2O. Neem cake 5.22% nitrogen, 1.08% P2O5, 1.48% K2O. So, looking at the nutrient source, you can calculate the nutrient requirement for a particular this source. Suppose for right hand side you can show nutrient source and quantity required. Suppose you have N requirement as you calculated previous one 87 kg per hectare. In case you have requirement 100 kg per hectare is the demand that requirement of the crop. That means, you need to name recommendations we need to apply 100 kg nitrogen per hectare as a external source. In that case what is your the source of nutrients? If your source is FYM contains 0.75% nitrogen if you are using FIM that contains 0.75% nitrogen, to meet the 100 kg N per hectare, how much quantity of FIM required, that is 13.3 tons. That means the 0.75 kg you are getting from the 100 kg, so 100 by 0.75 into 100 kg, that is your the recommended nitrogen, you can get 13.3. For water hyacinth, that contains 2% nitrogen. So, that is 100 by 2 into the 100, that 100 by 2 is equal to 50, 50 into 100, that is 5000 kg per required for the water hyacinth. That means, you see the water hyacinth contains 2% nitrogen, FIM contains 0.75% nitrogen. So, that is we are discussing, if the crop requires high amount of nitrogen, the source of compost should be rich in nitrogen, or you have to enrich the compost nitrogen, so that the requirement can be decreased. If you use FIM, the amount required 13.3 ton, but if you use the water hyacinth based compost, the amount is reduced to 5.0 ton per hectare. So, that means, by enriching the compost, you can minimize the requirement, because you have to meet the nutrient demand of the crop at the beginning of the season when you go for the organic farming. But wherever you see the chemical fertilizer urea, if you are using urea, it is very less amount, that is 218, as it contains 46% nitrogen, it requires only 218 kg urea per hectare. So, this is how to calculate the source of nutrients based on the requirement and the quantity of nutrient from different sources. Then the timing of application, what time you should apply, the third are right timing, when you should apply fertilizer, because the crops require fertilizer nutrients at the specific growth stages, especially cereal crops. If you give example of rice crops, so rice has the starting the phases from seedling stage to harvest stage. So, here you see the darker the shade, the better time of fertilizer application in rice crop. That means, this is one stage and here is another stage. The stage where the very critical stages we can say, that stage the crop should not suffer any type of nutrient either from the water stress also, and if the crop is highly responsive to application of the nutrients in these stages. At the 2 to 3 weeks after seeding, means is a clearing stage, the crop starts clearing, and during clearing, if there is a nutrient deficiency, especially nitrogen deficiency, then there may be less formation of tiller, because this is a tiller formation that leads to the final yield. If there is less number of tiller, then there will be less number of panicle formations, and hence there will be less grain yield. So, to have a optimum tiller, the good growth of the crop, we need to see that whether the crop has sufficient N requirement at this stage. If there is a stress, then nutrients should be ensured there is nutrient available to meet the requirement of the crop at this stage. Similarly, the other is panicle initiation stage, where you can see this stage during the panicle initiation stage, usually for the crops, the panicle which initiation, this is the stage, base stage, the panicle initiation takes place, there is a PI stage and the panicle comes out after 20 to 25 days. So, this the difference from the panicle initiations, and this is the panicle emergence, that is a PE, and this gap is around 25 days. And if there is any stress during panicle initiation, then there will be less number of grain formations, and ultimately there will be less in grain yield. So, this stage one of the critical stages in rice crop. So, the crop should not suffer any type of nutrient stress at this stage. So, so if you are supplying the especially the in a general, if you are farm-made manure in a general recommendation to farmers, especially for rice crop, you apply the 5 ton per hectare, and the fertilizer recommendation for especially for transplanted rice 150 kg N P25 per hectare, and if you go for the usually the phosphorus and potash used as a basal at the time of the sowing or the transplanting of the crop, because that time it is a very easier for the better incorporations in the soils better. So, they can be mixed well in the soil during the land preparations or the final purling time. And nitrogen, as it is subjected to various type of losses. So, nitrogen applied in split doses to meet the requirement of the crop at different stages as you have shown the left hand sides. So, these are stages which are very sensitive and the critical stages you can say for the nutrient deficiency. So, that time the nutrients should be applied at those stages. But if you go for the especially for the organic farming, if you do not apply only chemical fertilizers, we go for only organic. In that way you need to calculate how much required depending upon the source, what source we are using. And in case of organic, so what we have seen from our experience, you can apply also two splits. The 50% can be applied at the time of the final land preparations, if it is a fully decomposed manure that can be well mixed in the soils at the time of sowing or the planting of the crop, and the rest 50% can be applied exactly before the panicle initiation stage. So, in that case the yield can be maintained. At the same time, this will have the higher residual effect for the subsequent crop if you are selecting the cropping systems and the second crop is grown immediately after the first crop. So, that we can go for the split applications of this organic manure too. And then the right method, as say, so last one, the what method you can use, the right method of applications is you can go for the broadcasting, placement, pellet applications and through irrigation water fertigations. And the broadcasting, no, that is a inefficient method, not efficient. As a traditional method, farmers usually go for the broadcasting methods where the efficiency is very less, that means a higher loss of nutrients. You go for the either the basal application, that time we do incorporate the fertilizer, mix the fertilizer in the soils at the time of planting or the sowing of the crop, the basal, and then get top dressing as a broadcast when standing crop in the field, then apply in the soils as a top dressing. So, without proper incorporations. So, that is a broadcasting method which is less efficient, but you go for the placement method, say more efficient in the nutrient management, plough soil placement during the sowing time and the fertilizer placed below the seed zones as a plough soil placement, or it is a deep placement like the rice crops also. So, as the in case of the lowland rice or the standing water conditions, and there is a loss of the nitrogen through denitrification loss, to avoid the loss, the fertilizer placed in the reduced layers as we discussed earlier class, the deep placement layers where the oxygen is not present, in that zone fertilizer is placed. Then you can go for the band placement, that is a either by the hill placement for the orchard crops. Around orchard we make a trench, inside the trench we put the fertilizer and cover with soils, so hill placement, or row placement, that is a fertilizer cum seed drill. So, in a machinery, farm machinery, so there is a fertilizer drill and also seed drill. So, seeds are placed and so close to the seed row, then fertilizer placed and this is covered also, that is a row placement, especially for the row crops like the cereal crops, either you have the corn, wheat, those crops, even for rice crop also we can go for the row placement of fertilizer. So, looking at this, the 4 R's for nutrient management for precisions, either for the first R, as you say, right quantity, right amount of fertilizer, right quantity of fertilizers, right source and right time and right method of application. The whole process is to have a higher fertilizer efficiency, higher yield. So, finally, we need to calculate the fertilizer use efficiency. So, in terms of agronomic nitrogen N use efficiency or nutrient recovery efficiency. So, if we calculate the agronomic N use efficiency, so that is a grain yield in N fertilized plot minus grain yield in control plot where fertilizer is not applied by quantity of N fertilizer applied in fertilized plot. Similarly, the recovery efficiency you can calculate total N uptake in fertilized plot and total N uptake in control plot by quantity of N fertilizer applied in fertilized plot. So, I can give a small example here how to calculate this one. If there is a with fertilizer application, the yield is, so where you have applied fertilizer nutrient, so yield is 5.0 ton per hectare, and where you have not applied fertilizer control plot, yield is 2.0 ton per hectare, and the nutrient you have applied nitrogen dose, that is equal to 100 kg per hectare, the dose of nitrogen. So, if you calculate agronomic energy efficiency, so yield in treated plot, that is 5000 kg minus the control plot 2000 kg divided by amount of fertilizer applied, that is 100 kg. So, that is equal to, that comes around 3000 by 100, that is 30 kg grain per kg AN applied. So, that is what you say the agronomic efficiency, how much fertilizer applied. So, depending upon the source you are applying, from that source, every source we can calculate what is the use efficiency. The different source may have the different use efficiency, that some the use also varies from the either compost or energy compost or the different water hyacinth based compost or paddy straw based compost. So, they have the different fertilizer use efficiency. So, finally, the purpose is when you go for the nutrient management, our main objective is to utilize all the sources of possible nutritions and to have a better yield, enhancement yield, and with minimum use of nutrient. That means, how we can increase the fertilizer use efficiency. That means, we can increase fertilizer use efficiency when you can have the higher yield, at the same time less loss of nutrient. Less loss of nutrient means that you can minimize all losses through either through different method, by applying different method, either band placement, so that the efficiency can be better, yield can be better, and the use efficiency can be better. So, this so this two lectures, introduction to organic management. So, you will be able to get knowledge, take knowledge on. So, what are the specially for the land management or the planting techniques in organic farming systems, and the how to diagnose the nutrient deficiency symptoms due to different macronutrients or micronutrients, and how we can analyze the available nutrient present in the soils, and how we can calculate the recommended nutrients, how much nutrient to be applied for a particular crop, for a particular soils, and the method of application, how we can apply, so that we can have the higher fertilizer use efficiency. At the same time, yield is also increased or improved. Okay. So, thank you very much.